Hello, continuing on our working coordinate geometry, we're going to be looking at the area of triangles. Now we already know a lot about the area of triangles. It's some of the earlier maths that we ever did. So we know that the area of a triangle is half the base by the perpendicular height, a half BH. We already know that. That's still true. It's still a tool we should have in mind. Last year you would have learned about the area of a triangle being a half AB sine C, and we should know that that is in our log tables on page 16. Both of those tools are valid. Both of those tools help in exam questions based on the stuff we're doing today. So just because it's from an earlier part of the course doesn't mean it's not relevant. It should be tools that we have available to us. All of the ways of getting the area of a triangle are valid in an exam setting, so they should all be available to us in our minds as we look at these questions. Now the new formula for today is the one that we have here. Area is equal to a half. We have our two vertical lines, which mean absolute value or modulus or the distance, as we saw the last day. So really it just means the magnitude or the size of, and in practice it's going to mean that we take the positive answer. So no matter whether this sum ends up being positive or negative, we're going to take the positive answer from it. There's a caveat to this formula which is not very obvious in your log tables, and it is that one of the corners of our triangle must be at 0, 0. Now you might be able to use the anchor of the fact that there's only two coordinates given in this formula. That kind of implies that something funny must be going on with the third corner, or vertex if you prefer, of our triangle. And in point of fact, this formula only works if we have one of the corners, one of the vertices of our triangle at 0, 0, at the origin. So let's have a look at a situation where that is the case, and then a situation where that's not the case, and how we can solve both types of problems. So I have my blue triangle down in the bottom left of my screen. So I have O, P, Q are the vertices, the corners of my triangle, and I want to know the area of this triangle. And I go to my log tables, page 18, and I can see that I have a formula for that, and I can see that one of the corners of this triangle is at the origin, is at O. It's at 0, 0. So what I'm going to do for this type of question is write down my coordinates. So O is at 0, 0. It's at the origin. P is at 2 minus 3. So in the door 2, down the stairs minus 3. So 2 minus 3. And Q is at 6 minus 2. In the door 6, down the stairs minus 2. Now I have one corner that is at 0, 0, so I can use this formula straight away, and I have an x1, a y1, an x2 and a y2, so I'm going to write them in: x1, y1, x2, y2. I've written down the information I've got in the question. This is my first step every time. Second step every time is going to be writing down my formula. So the area, and I should have my subscript in so I keep track of what I'm doing, because again there can be more than one triangle in the question. So O, P, Q is my subscript, and I have my formula here. Be very careful here. These subscripts are muddled in this formula in a way they aren't in any other formula that we use. So read it very carefully from the log tables each time. So x1 by y2 minus x2 by y1. Now I've written down my points, I've written down my formula, I'm in a position to sub in. So I have a half of x1 is 2, y2 is minus 2, everything in brackets because we are multiplying terms together. X2 is 6, and y1 is minus 3. Now when I simplify that down, I get minus 4 plus 18 half of minus 4 or plus 18 is 14. I happen to end up, sorry, we'll do this first. We know that this means take the positive. Our modulus, our absolute value, our magnitude, whatever you want to call these lines here, means we are going to take the positive answer. In this case, it's already positive. Life is easy. But it won't always be positive. I would actually write that in as I'm doing the question. My modulus sign means I'm taking the positive. Now I've turned that into just normal multiply because I've taken the positive, and I have a half of 14 is 7. Now my job's not done because this is an area. So what do I need to write down? Units squared for an area. And that's my final answer. I've written my points, I've labelled them, I've written my formula, I've subbed in, and I've shown enough steps where I can see all of my work being done, where everything's coming from, and I have my units at the end, units squared for area. Let's have a look at a situation which is a touch more complicated, where we have a triangle here, and we've got no corner, no vertex sitting at the origin. What are we going to do here? Well, we know from coordinate geometry from all the way back in first year that we're able to move points in a very consistent and understandable way in mathematics when we have our coordinate system. We can translate points. And if we translate, if we move each corner, each vertex of our triangle by the same amount in the same direction, we'll keep its shape. Therefore, we'll keep its area. So what we're going to do if we don't have a corner of our triangle sitting at the origin is we're just going to move the whole triangle down so that one of the corners is at the origin. And it's going to be just a normal translation. Now, translations don't get touched on very much for most of the higher level course, but that's actually a little bit of a issue for us because translations can be very helpful for solving some problems that are very complicated to do algebraically. We're going to see that later on, particularly when we touch on the circle. So keep in mind, translations aren't just about first year. Translations are going to be very important now as well. So they're not a tool to dismiss. They're very important, particularly when we're doing the coordinate geometry part of our course. Now, let's get into it. I'm going to write down my 3 points so that I have an anchor for where to start. I have A is at 1, 2, in the door 1, up the stairs 2. B is at 2, 5. C is at 5, 2. Now, I'm going to do translation. I can translate any one of these points to 0, 0. But I want to make life easy for myself. What's the smallest amount of work? What's the easiest to visualize translation I can do to get one of my corners to 0, 0? Well, I think moving A to 0, 0 is the easiest point to move. I have to do the least amount of work. But you will get the correct answer by translating any of them to the origin. So the way that I write translations, and the way that I strongly recommend that you do, is we are going to write out our coordinates for each one of our points, and I'm going to pick the one I'm going to move to the origin, or to wherever I need it to go, in this case the origin. I have my x coordinate that I'm starting with. What do I need to do with it? Well, I need to subtract 1. I'm at x1, I want to end up at x0, so I need to subtract 1 away from my x coordinate. From my y coordinate, I need to subtract 2 to get down to 0, 0. So this is the translation. This is the way I need to move A, and if I use a visual to help myself, I am starting at A and I want to get to the origin. So I'm going to subtract 1 from the x and subtract 2 from the y. So I'm going to end up moving in that direction. So I'm going to subtract 1 from my x and 2 from my y. I'm going to end up moving in that direction with B. I'm going to subtract 1 from my x, 2 from my y with C. So this is going to be the location of B's image, and C's image, and A's image, which is going to go to O. So I can see now I've got my triangle in blue, my new triangle in blue, and within the bounds of my ability to draw, you can see that it's exactly the same shape as my original red triangle. And remember that we have this notation of C dash for the image of C, B dash for the image of B, and A dash for the image of A, which is also at the origin, which we usually call O. Now, let's finish our translations here. We're going to do the same translation for B and C, and see if we get the same thing as we did from doing it graphically. So subtract 1 from the x, 2 from the y, subtract 1 from the x, 2 from the y. Where does B end up? Minus 1, and we end up at 1, 3. And from C to C dash we end up at 4, 0. Now I have one of my corners at 0, 0, so I can call this x1, y1, x2, y2, sub into my formula area of A, B, C, write down the formula on the page immediately before you're going to sub into it, even if you already have it on the page elsewhere. Half on 1 by 0 minus 4 by 3. So I have a half of minus 12, and I know that my modulus means take the positive. Take the positive when I have my modulus. So that becomes plus 12. I always take the positive. That ends up being 6, and I know I'm dealing with area, so that's units squared. But something should have jumped out at everybody, and it's deliberate on my part in this case. What's the easier way of getting the area of A, B, C if I was given the picture I was given at the beginning of the question? I know from way back in first year that the area of my triangle is half the base by my perpendicular height. The base of ABC, or a base of ABC, the line AC can be taken as a base, is 1, 2, 3, 4 units long. So half base by height. B is equal to, the base is equal to 4. And for that base, what is the perpendicular height? 1, 2, 3. So the perpendicular height from that base is 3. So the area would be a half 4 by 3, which ends up with 6 units squared. Critical that we do not forget that we have the simpler tools available to us. We get the same answer from this amount of work as we do from this amount of work. We get the same amount of marks for it in the exam. That's not that you can always do this, but it's important to remember that we have the whole range of tools that we've learned all the way up from primary school available to us, and particularly taking this pictorial approach is extremely important for being able to figure out a lot of these questions. If we can learn to sketch well, it massively increases our chances of success at higher level.